Good morning, sir. Good morning, my own colleagues in the dais. Probably Dr. Sharaf had given me a tough job. He had made me, I think, probably 2 months back. These are the few things only you have to cover. Try my level best to attend already covered in this session. Thank you, sir. So, more financial interest. So, let me just come to I think everybody knows that in the way back 1960, Charles Kelman invented this type of classification. Then you all know that why this buzz sound is due to the harmonic tones of the handpiece and the tape. Then just brief about the mechanism of action. There is two types of mechanism of action. Then one is microcavitation, where there is a implosion of the bubbles, and second one is jackhammer effect, which is nothing but the mechanical breathing. So I come to few of the terminology in classification. One is flow rate, measured in terms of cc per minute, where the volume of the fluid that exceeds the eye through the paper tube. Then vacuum, it is always measured in millimeters of mercury. It is regulated by the pump, paper pump, that assists in holding the fragment. Next comes to is the power, that normally measured in terms of percentage. It is the distance the phaco tip moves from a position of rest, which adds in emulsification. So I'll come straight away to the different types of pumps. As you all know that peristaltic, venturi and diaphragmatic pump. I am not talking about the diaphragmatic pump, which is almost outdated. I will be only touching upon peristaltic and venturi pump. So, peristaltic pump, what exactly it happens? Where the pressure differential created by compression of tubings in a rotatory motion. By doing that, there is an aspiration line pinch and milk between the roller and housing. So, pressure differential draws fluid into the aspiration line, and always here vacuum depends on occlusion. You have to remember this. So because of that one, there is more reaction time, of course, more safe for beginners. And since it is vacuum not depend upon the occlusion, there is more movement of the tip inside the anterior chamber with the stuffing action. But one more thing, if the flow rate is less, always you can feel the very poor quality. And one more important thing, occlusion depends on the fuel of the tip. So these are the other features. As I already said, slower the vacuum rise time, always higher the safety margin. Of course, that gives rise to increased surgical time. Once again, rise time is dependent on aspiration flow rate. Aspiration flow rate and vacuum can control independently. Just for example, when you are sculpting in your first position, you need only zero vacuum phaco, but when you are chopping, that time you require a high vacuum phaco. So let me come to venturi pump, which is driven by compressed nitrogen or air. Vacuum and flow rate are proportionally linked on a venturi pump and cannot be independently adjusted. And one more thing, I think this was your knowledge, the parameters of flow rate does not exist in venturi pump at all. So always vacuum builds even without occlusion. So once again, I just want to highlight about these are the difference between peristaltic and venturi pump. Peristaltic is always flow based, venturi is vacuum based. And here in peristaltic, always vacuum created only when phaco tip is occluded by cataract material. But in venturi, vacuum created instantly via pump once the surgeon presses his foot pedal. So very you should understand, you no need of any occlusion of phaco tip. And flow is always in peristaltic always constant until the occlusion, but in venturi flow varies from vacuum level. In peristaltic, it drains into the soft bag. In venturi, normally fluid drains into the rigid cassette. So, see, I'll just next come to the foot pedal. So, there are, as you know, first step is irrigation. There is a different tonic sound for that first step, which is irrigation. Second step is irrigation and aspiration, and third one is ultrasound. So third one is irrigation, aspiration and ultrasound. So let me come to the handpiece. What are the different parts of this handpiece? You can see in the photo. On top you can see that port is for aspiration, that is for outflow. The down port is for inflow, and the middle one for delivery ultrasound power. And one more thing, you can see the silicon sleeve around the tip. You can see the ports there. From the 80% of the irrigating fluid enters through this side port. Only 20% comes from the main port. So as I already said, the silicon sleeve from the port 80% comes out and 20% comes out from the front. And the down is showing a irrigation line. So let me come to the phaco tip design. Phaco needle, nothing but it's a hollow with a distal opening functioning as the aspiration port. Irrigation fluid flows through the two ports located 180 degrees apart on silicon sleeve. And this phaco needle we thread directly into the internal mechanism of the handpiece containing the ultrasound generation unit. So this phaco needle always made up of titanium. Due to that it resists fragmentation, and depending upon the different companies it either can oscillate longitudinally or partially. And there are different varieties like 0 degree, 15 degree, 30 degree, 45 degree. And stroke length measured by 2 by 1000 or 6 by 1000 in inches. So as I already said, just to once again highlight you, the front one what you can see is sleeve, then bevel, then angle. So these are the few tips as I already said, 0 degree, 15 degree, 30 degree, 45 degree. Each one has got its own advantage and disadvantage. So 0 degree needle normally occludes readily when the tip is parallel on the surface. So it's very good for cavitation theory. And here cavitation wave directly in front of half millimeter from the tip. Coming to the 30 degree, here 30 degree generates cavitation at 30 degree angle from the bevel and 1 mm in front of it, similarly for the 45 degree. So as I said, 45 degree is also curved dense, especially helpful in dense nuclear efficiently, mainly used for sculpting by Jacob mechanism. Especially those beginners, they want to start with the sculpting, then followed by chopping technique. 45 degree really helpful. So what I said, I'm just showing in the figure different types of tips. So once again, I want to come back to the different parameters. First is there is flow rate. It is measured in cc per minute. How fast the things, that is how fast the cataract material is coming to the phaco tip, more the flow rate, rapid movement of the material to the tip. And vacuum, after occlusion of the phaco tip by nuclear material, how strongly those materials are held up at the tip. So more vacuum, more strong hold. As I already said, this is a small schematic presentation. If the flow rate is slow, then the material will come to the tip slowly. If the flow rate is high, it will come quite fast. Even like in vacuum also, if the vacuum is more holding power. Even in power, less power means less cracking ability, more power means more cracking ability. So, as I said, let me come to the one more terminology in phaco, that is surge. I think everybody should be aware of this. It's defined as sudden increase in outflow beyond the compensating the capacity of inflow, resulting in collapse of anterior chamber, normally occur after a full occlusion is abruptly relieved. So, I'll come to the one more terminology, compliance. What it means compliance? Change of the tubing shape and volume when it is put under the negative pressure. When the tip of the phaco needle is occluded, negative pressure is built in the tubing, thus the higher the compliance, the more chance in the volume. So when negative pressure is created, highly compliant tubing collapses on itself, reducing its inner volume capacity. So when the occlusion breaks, the tubing returns to its original shape for a temporary imbalance of exist, causing a rapid exit of the fluid from the antechamber, thus causing insult. So there is an advantage. See, if you are doing lot of people repeatedly autoclaving the tubings, this tubings will become more and more rigid. The chances of surge is more higher. That's why people nowadays tend to use disposable tubings because of this reason. And as I already said, it is inversely related to the outflow resistance. The more the compliance, once again, what I said, stiffness and diameter of the tubing, the lesser the resistance. Let me come to the one more thing is venting. What it means? It is a process whereby negative pressure or vacuum is equalized to atmospheric level to, it is a minimizing surge. So vent is favoring surge. So neutralizing the aspiration line vacuum between the occlusion at the handpiece and the pump that prevents the flow pump vacuum build up past the panel present level. So in air venting what happens, there is a slow rise time, but in fluid venting always faster the rise time. This is just to show about where exactly you can see how the fluid will address to this part. So once the occlusion of the paper tube by nuclear fragment, vacuum created, when vacuum reach to the maximum preset level, vent valve will open and some air or fluid will enter into the system. So this will happen to prevent exceeding vacuum from preset level. So as I already said, when it reaches that preset level, vent valve will open, either air or fluid enters into the antechamber. So, what I just wanted to say, tell that fluid vent is always better than air vent. So, how exactly? See, once the air expands more in the vacuum, fluid expands less. Once occlusion breaks, air contracts more, so fluid contracts less. So, coming to my take-home message towards you, advance in paper technology continues to improve our ability to manage most challenging aspects. Although such sophistication is senseless without proper understanding and properly configuring our paper machine, which allows us to deliver better performance. Thank you very much.